Hey, what's up, guys? Uh, this is Chung here. Not today, same day actually. I just uploaded another video. So, but I still would like to record another video. Uh, regard about this one. Another tree problem here. Number 662, maximum width of binary tree. It's a, I would say the medium one. I like it, so I will give another upvote here. So. Okay, you're given a binary tree. Write a function to get the maximum width of the given tree. So what is the width, right? The width is on the same level of the tree on the distance from the leftmost node and the rightmost node. So for example, this one here, and yeah, and the non node will also be counting as a node, right? So for example, here with single one, of course, the distance will be one, right? With three and two, so the distance will be two here. For level two, will be three and two. How about here? For the last level, it's going to be 5 to 9, right? What's the distance between 5 and 9? That's one, two. There will be a missing one here, right? So 1, 2, 3, 4. So it's going to be 4. That's why we have 4 here. Same thing for this one. The max level is 2 basically. One node is always 1. 3 is 1. But with this one, 5 and the 3, the level will be 2. That's how we get 2 here, right? So how do we think about this, right? And this is the binary tree here, right? Because okay, I would tell you guys how was I thinking. So at the beginning, I was thinking of, every time I would sit, because I remember I did one problem is that, I mean, to traverse this node like vertically by the horizontal like positions. I think also that's why at the beginning I was thinking, okay, I'll start with the root node with 0 as axiom equals to 0 and every time when I go to the left, I uh I minus 1, and every time I go to right, I plus 1, right? And then in the end, I just compare the the left the leftmost the position and with the rightmost position. But then there's an issue for that. Let's say for example this one, 1 minus go to left, so 3 will have minus 1, 2 will have 1, right? But if from 3 we go to the right side, this 3 will become 0, right? And if there's a 2 here, if the 2 has a left node here, let's say I have a left node 7 here, 7 will also have a 0 uh, position, x position here. So that will basically, if we use the position, this will have 2, right? Basically, the 9 will have 2. If we use 0, from 0 to 2, we'll get 3. But 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 then we'll be missing this 7 here, right? So that won't work. So then how should we think about this? If you can think about if okay, so what we should think about is instead of using that positions, we should like remember the index on each level. Let's say here 1, 2, 3, 4, 5, 6, 6, 7, right? So let's say for example with this three level binary tree here, on each level the index will be 0, right? This is 0, this is 1, 0, 1, 2, and 3, right? if you watch it closely, so as long as every time when we traverse this tree, we can save the index along with the node, and then when we do the level traverse, which will also be called the breadth first search, right? When we do that, we can just simply get the first index and the last node in that of that level traverse, and then we just simply get the distance, right? And then the question comes down to how can we calculate the node's index, right? Let's say this one is not there, right? It doesn't really matter as long as we have 4 and 7. We don't care about this one is there, right? We because we have the index of 7 here, so that's all we need. So how can we calculate? So if you watch closely, I think it's pretty clear. So let's say, for example, 3 here, right? When we see this left node and right node, you can always see here the the left the left sub node of this current node, the index will be what? The index will be the the previous the the previous index times 2, right? That will be the left sub subnode index, and the right one will be this 1 times 2 plus 1, right? Y times 2 because on the previous one, each of them will have up to 2 nodes, right? That's why when we calculate the current subnode index, we just need to use the current node index and then we times 2 to be the left one, and then we plus 1 to be the right one, right? You want to keep doing it, it's like 8, right? 8, 9, something, right? 9, and then here it's like 8, 9, 10, 11, 12, 13, right? 0, 1, right? How about here? 0, 1, 2, 3, and here, so this one has a index 2 here, right? So and here the 12 index will be 2 times 2. This one will be 4, right? And this one will be 5, right? That we use this index times 2 to be the left one, and we do times 2 plus 1 to be the right one, right? And then I think that's all we need to calculate this thing here. Okay, so let's try to code it here. And since we're doing the row level traverse, which will also be the breadth first traverse, right? So we'll be using a queue here. We'll create a queue first, collections.dequeue, right? And then we push the root node to it. Oh, and remember, we want to when we push each node to the queue, we also want to record its index, right? The node index. For the root one, obviously for the root node, the index will be 0. So we just do and we need to do a tuple here because 0, right? Oh, here. And then we just do a level traverse, level order traverse or breadth first search, right? We do what? We do a while queue, right? While queue. Then for levels traverse, we do this, right? Do this, like every time we just get the length of the current queue, right? Yeah, and we'll also have the result here. The result will have the final result of the width of the tree. do a max, right? Because we want to keep getting a bigger one. Then we do what? We do like I said, we have to do a queue, the last one, right? So since the last the last character, I'm sorry, the last element in the current queue will be the last element will be traversing, right? Because here, yeah, we need to do it before the for loop. Because before doing the for loop, so all the elements in the queue will be the node for the current level, right? So and then we just get the last one, the index of the last one, and then we just minus the first one index, the first element index, right? And then in the end we plus one, the to be the current level's width, right? And then we just compare with the previous result, we get the bigger one, right? And then that's how we do this like update the width every time before doing the loop here. And then we have to finish of course we have to keep going down to the next level here, right? How it's uh, regular breadth first search or level search, right? If right, and then we do a node here, node equals to q, we pop from left, right? That's we do a level traverse. If node have left has a left node, we just append the node into the queue. Same thing for the right node. If the right side has a sub node, which also append the nodes to the right side node to the queue, right? Simply return the result, right? So here we're not maintaining the level number because we don't care. We don't care about their node. All we need is we just need to know the width, right? So we don't need the level variable here to keep track of the which level is that. And sorry, okay. My God, I confused myself. Oh my God, sorry. Yes, so uh, I forgot what we need to do here. Sorry, guys. Yeah, I just completely confused myself. So, like I said, when we when we push each node, we need to get the new node's index, right? How, right? So the index will be when we pop, right? When we pop, since we're also storing the index along with the node here, so every time we pop the node current node, we also get the current node's index, right? And like I said, when we do the push here, uh, besides the node itself, we also need to calculate the new node's index, right? For the left node, like I said, like we discussed, it's going to be the current index times 2, right? And same thing for the right node. It's going to be the index times 2 plus 1. Yeah. Sorry guys about all this like hassle here. I can certainly do another video, but I just want to show you guys maybe the whole process, maybe how stupid, what kind of stupid mistakes I can make, right? So yeah, so with the index and then the new index we push, and then we just in the end we just return the result after we finish traversing the tree. I think that should do it. Yeah, I think I'm missing another right parenthesis here. Mhm. Cool. All right, pass. Cool, guys. Real quick, so real quick to recap. So the key idea here is that we need to keep track of each node's index on the current level. So the way we're doing it is we every time we have the previous node index, we just for the left one we do a index times 2 and the right one index times 2 plus 1. And then at the very beginning of each level traverse, we just update the width with the current rightmost node and the leftmost node. Cool. Thank you for watching the video, guys. All right, I'll see you guys soon.